This is the incredible story of how human ingenuity, armed with, get this, little more than cardboard and duct tape, rescued 3 men from the freezing, silent emptiness of space. You know the line. It's maybe the most famous understatement in history, but for the crew of Apollo 13, those 5 words, they signaled the start of an absolutely desperate fight for survival. Okay, just imagine this for a second, right? You're out there 205,000 miles from home. You're hurtling through the void at 4 miles per second. And then, ram, a violent explosion just shakes your tiny spacecraft to its core. The master alarm starts screaming, and when you look out the window, you see this silver cloud just venting into the abyss. And you realize that's your oxygen. That's your power. It's bleeding away into nothing. So to really get how they pulled this off, we're going to break it all down. We'll look at 6 critical stages of this crisis, from that first bang all the way to the nail-biting return to Earth. All right, first up, a bang in the block. You know, the mission had already had a bit of a rough start, a crazy shudder during launch that shut down an engine early. But for 2 days after that, everything was, well, it was running smoothly. The crew was on their way to the moon. But then, 56 hours in, Mission Control makes a pretty routine request. Pilot Jack Swigert flips a switch to stir the cryogenic oxygen tanks. I mean, this is a totally standard procedure, just to get an accurate reading. But 2 minutes later, a spark from some faulty wiring ignites the pure oxygen inside Tank 2. And the explosion, it didn't just destroy the tank, it crippled the entire command module. And that brings us to the dying Odyssey. Down on the ground, Flight Director Gene Kranz and his team, they knew immediately how bad this was. The command module, which they called Odyssey, was dying. Its life support, its power systems, they were all failing and fast. The mission to the moon? That was over. The new mission was just to get these guys home alive. And this timeline here really puts into perspective just how long they had to survive. The explosion happens on April 13th. They won't splash down until the 17th. That's 4 agonizing days in a crippled ship with absolutely no room for error. Their only hope? Power down the command module completely and move into the lunar module. And this right here lays out the sheer scale of the problem they were now facing. The lunar module Aquarius was basically a space taxi. It was designed to keep 2 guys alive for maybe a day and a half. But now, it had to become a lifeboat for 3 men for 4 whole days. It just wasn't built for this. And that led to their very first life or death puzzle. Which leads us to the square peg problem. Okay, so with 3 men crammed into a space built for 2, the air was quickly becoming toxic. Carbon dioxide was building up to lethal levels. They were, and I mean this quite literally, breathing themselves to death. So here's the crucial point. They had spare CO2 scrubbers, but they were the square ones from the dead command module. The life support system in the lunar module, it used round canisters. So back on the ground, engineers were faced with this problem that sounds childish but was deadly serious. How in the world do you fit a square peg in a round hole? The solution they came up with is just legendary. Engineers literally dumped a box of everything available on the spacecraft onto a table and, under insane pressure, they invented a fix. They instructed the astronauts to build an adapter, which they lovingly called the mailbox, using ripped cardboard from logbooks, plastic bags, hoses from their spacesuits, and, of course, a whole lot of duct tape. It was this ugly, improvised piece of hardware, really, but it worked. It absolutely saved their lives. Okay, problem 1 solved. Now for surviving the deep freeze. So the air is clean, but another problem was becoming critical. See, to save every single precious drop of power for re-entry, they had to shut down almost everything, and that included the heaters. The temperature inside the cabin just plummeted. It dropped to around 3 degrees Celsius, just a few degrees above freezing. The men were cold, they were exhausted, they couldn't sleep. But you know what was even worse than the cold? The condensation. Water was forming on every single surface, including the electrical panels they would desperately need to power back on for re-entry. Not good. And that brings us to the power-up gamble. Yeah, that condensation posed a huge threat to their final and maybe most complex challenge, restarting the command module. This was a spacecraft that was never, ever designed to be shut down completely in space and then restarted. No one had written a procedure for it because, well, it was considered impossible. Back in Houston, astronaut Ken Mattingly and flight controller John Aaron were working tirelessly in a simulator. They had to write an entirely new power-up sequence from scratch. one that could bring the frozen, dead command module back to life, using only the tiny amount of power left in the reentry batteries. Every single amp was accounted for. They read the steps up to the exhausted crew, one by one, knowing a single mistake would be fatal. And the stakes just couldn't have been higher. One engineer on the ground famously said that if they got this power-up sequence wrong, the ship would become a tomb. It would leave behind a collection of perfectly preserved corpses to orbit the sun forever. Chilling. Which leads to the final chapter, a successful failure. But they didn't get it wrong. Against all odds, the power-up sequence worked. Now came the final act, surviving that violent plunge back to Earth. So for their final course correction, a maneuver that had to be absolutely perfect, the crew's computers were off. They had to do all these complex calculations by hand using slide rules. I mean, can you imagine? It was a triumph of basic math and just steady nerves guiding them home. And on April 17th, they splashed down safely in the Pacific. So yeah, Apollo 13 never made it to the moon. But it really forces us to ask a bigger question, doesn't it? A mission that fails its main objective, but succeeds in bringing its crew home through sheer brilliance and determination. Isn't that one of the greatest successes we've ever achieved? It stands as perhaps NASA's finest hour, a testament to what we can solve when we simply refuse to fail